Okay, wrapping up chapter 2. We have one more video after this for the first unit. All right, so this is talking about density. So objects that sink in water are more dense than water. Objects that float in water are less dense. So there are some examples over here of cork that's floating, that's floating, water that's water, aluminum, and lead that are both sink. So the learning goal for this one is to learn how to calculate the density of a subject using the density to calculate the mass or volume of a substance. So I got, again, another fantastic table that's in your book. Okay, it tells you some common densities, okay, the liquids, gases, as well as solids, and the different densities so that we can compare them. Okay. So the density compares the mass of an object to its volume. So the definition of density is mass over volume. So you can see that the density of solids and liquids would be grams, which is the mass, over the volume, which would either be centimeters cubed. When again, we told you that centimeters cubed is the same as milliliters, and that's also the same as a cc. So that's the same, right? So the density of gas would be grams per liter. And again, remember that 1 milliliter is the same as 1 centimeter cubed, which is also the same as a cc. So there's a fun little thing that you can do, and we can figure out volume by displacement. And so I would love it if you guys did this. If you have a cup and a scale, you can play around in your kitchen and do this. But a solid, when it's completely submerged in water, dissipates its own volume of water. So a volume can be calculated from the difference in volume, right? So for instance, if we have 45 milliliters and we subtract 35.5 milliliters, because this was the original volume, we put an object in, and that was the new volume. When we subtract that, we can figure out that the difference was 9.5 milliliters. And then again, using that conversion of the similarity, that would be 9.5 centimeters cubed, right? So this is just a fun little thing that we can do, and it's very, very helpful. So again, this is how we would do it. The density of the zinc object is calculated from its mass and volume. So you can see that our volume increase from before when we put the zinc in to after we put the zinc in is going to be this here. So what we would do is we would subtract 45 from 35.5 milliliters to figure out the volume of water that was displaced. Then we take the mass of the zinc that was given from that table, and we put that over the displaced volume and equate it out. And so we can tell that that zinc that we put in there was 7.2 grams per centimeters cubed. So it's actually a very strong way to measure volume, okay, of like a solid object or whatever, and like an asymmetric object as well. So here is a little study check for you. So what is the density in grams per centimeters cubed of a 48.0 gram sample of metal if the level of water in a graduated cylinder rises from 25 milliliters to 33 milliliters, 0.0, after the metal is added? Okay, all right, you have it. All right, so let's set this up. So again, we have 48.0 gram sample of metal, okay, and the water raised from 25 to 33. So what we would do is we'd have to figure out the volume of water that was displaced, so 33 minus 25, and that gives us the 8. And we put that mass of the sample in grams over the volume that was displaced of 8 milliliters, and that ends up giving us 48 divided by 8 is 60 grams per milliliter would be the density of that sample of metal. Okay, so it's just a really cool way to figure out densities and things if we can't actually measure it. So here is another awesome flow chart, kind of like similar to what we did before, of problem solving using density. So if the volume and density of a sample are known, the mass in grams of the sample can be calculated by using the density as a conversion factor. So what we're going to do is state the given and needed quantities, write a plan to calculate it, write the equalities and their conversion factors, and then set up the problem to calculate the needed density. Okay, so here we are. For example, if Johnny took 2.0 teaspoons of cough syrup for a cough, and the cough syrup had a density of 1.20 grams per milliliter, and there was a 5 milliliters in 1 teaspoon, what was the mass in grams of the cough syrup? Ah, okay, break it down. What were we given? We were given that he took 2 teaspoons of syrup and that the density of the syrup is 1.2 grams per milliliter. What do we need? How many grams of syrup did he take? So, okay, let's write this out as a plan. So we have teaspoons and we need to turn that into milliliters, and then we have to take the milliliters and turn that into grams. All right, not so bad. So what are we going to do? 1 teaspoon equals 5 milliliters. Okay, 1.2 grams equals 1 milliliter. Okay, not so bad. All right, so let's set these up. We need teaspoons on the top to be able to cancel these out, milliliters on the top to cancel this guy out. So what do? 2 times 5 times 1.2. They cancel each other out, and these are both ones, so we'd be dividing by 1, okay? And so 2.0 teaspoons gives us 2 sig figs, so we need our answer in 2 sig figs, and so the answer would be the 12 grams of syrup. So you see, when you follow a plan and you actually write it out, it's not so horrible. Like when you first get it, you're like, oh my good Lord, what? But take a step back and actually say, okay, we got this step by step, and you'll be good. All right.